Question number 5a. The diagram below represents the graph. We have this business here. Write down the values of a and b. So what we have here is a quadratic, and these points here are the points of intersection with the x-axis, and these happen to be the roots. These happen to be the solutions of the graph. And we know that when we factor this quadratic, we have it such that if we have a negative root, this sign must be positive. So the x value here, the root is negative 2/5, but then if I were to just write the factor x minus 2/5, right away we recognize that negative some value means this point is to the right, but we want this point to the left. We want the x to have a negative value, so we actually have to choose an a value such that it's positive. So we want the a value to be such that this ends up being positive, because when we have x plus 2/5, it means the solution is to the left, which is the case here. So how do we do that? We choose an a value of negative 2/5. If a equals negative 2/5, we have x minus negative 2/5 becomes x plus 2/5, which is what we wanted, because this here, the plus sign, means the root is to the left of this y-axis. So the a value here is negative 2/5. Now what about the b value? Now for this factor here, x minus b, we want it to look like x minus 3, because this value of 3, and it's to the right, it's a positive value, means we're going to choose x minus 3 this way. So the b value should be 3. Let's think it through. If b equals 3, we're going to have x minus 3, which is correct, because when we have a negative factor here, x minus some number, it means that root is to the right over here, which is correct. Part 5b. The function has a maximum point, q. Find the x-coordinate. As you can see here, this q point, the x-coordinate is simply the coordinate that is halfway between. These parabolas are well balanced, they're symmetrical, and this axis of symmetry is found by simply taking this higher number, the x value, minus the smaller x value, and then dividing it by 2 to find the distance between the 2 points and add it to the original value. So to find the x-coordinate of point Q, we're going to take 3, that's this number here, minus this number here, which is negative 2/5, and this happens to be the distance. This is the distance. So the distance between these 2 points is this, which happens to be, just using algebra, this is 3/1, which is the same thing as 3 times 5 is 15, 15/5. So we have 15/5 plus, these two negatives become a plus 2/5, which becomes 17/5. Now this here is the distance, and we want to divide it by 2. So what we have here is 17 divided by 5/5 divided by 2 is equals to 17/10. So the distance from here to here is 17/10. What I did here is 17/5 divided by 2 is the same thing as divided by 2/1, which is times 1/2, and you can get the same result. So what we do finally to find the actual x-coordinate of Q is to take this 17/10 length, which is halfway across, and add it to this original position of the x, which is negative 2/5. So the actual Q's x-coordinate is going to be 17/10 plus negative 2/5. And a plus and a minus becomes minus. And we're going to just cancel out these 5 and 2, rewrite it as 10 and 4. 17 minus 4 is 13. And so our actual Q's x-coordinate is going to be 13/10. And we're not quite sure what the y value is.